discuss. So the first thing, right, today when I'm not going to make you, how I say, whenever you have these types of questions, in the CXC exam, you are going to have to write a paragraph explaining how you got the answer. We're going to bypass that today. I'm just going to focus on actually just getting the answers and figuring out which rule we used. And when we perfect that, then I will show you how to word out your answers afterwards. So quick question, looking back at your notes, which rule did you all decide to use? It has 7 rules. What was the key rule in this particular question? Right, it has to be rule number 2. This is rule number 2. So for those who got it wrong, turn back and look at rule number 2. Now let me just explain what rule number 2 is, right? Let's go through it again. Rule number 2 tells you that if you have an arc, A, B, right? So remember, an arc is just part of a circle. Rule 2 simply states that if you have an angle starting at A, hitting the circumference, keywords, circumference, and bouncing back to B, there must be an angle. I'll call this angle common A. Now, it also says that if you have another angle starting at A, but this time it goes to the center of the circle, so I'll use this dot to represent the center, and it bounces back, there will also be an angle here. Now, from just looking at these angles, you can clearly see that the green one is bigger than the black one, well, the A, right? B is bigger than A. The one at the center, there's always be twice, sorry for the bad handwriting here, twice as large. So, but this one is the bigger one. So if here is 50, the one at the center is 100 degrees, right? And just to clarify, for rule 2 to work, if you look back in the notes, I said something about eyes and how the eyes have to be looking in the same direction. So if you convert this to an eye and you convert this to an eye, you notice A is looking downwards and this one is looking downwards. The 50 is looking downwards and the X is also looking downwards. Make sure when you are applying rule 2 that the 2 eyes are looking in the same direction. There are trick questions in the exam that resemble rule 2, but when you look at the eyes properly, the eyes may not be looking in the same direction. In a case like that, that is not rule 2. So let's make this question a little bit harder. Let's just say, let me put this in here, make it look a little bit neater. So I'll put in the 100 inside here, right? So the 100 is this angle here. Let's say that I come and tell you that this angle is 40 degrees. I just said it's 40 degrees. I want you all to try to find this angle for me, the pink angle. Knowing here is 50, well, you now know here is 100, and this angle is 40. Find the pink angle. Now, I see a lot of people are saying 40. Let me just clear up why this is not rule 1. Remember, if you look carefully at rule 1, if you have an arc, right? Rule 1 says that if you have an angle starting at A, hitting the circumference and bouncing back to B, there must be an angle. I'll just call it A. If another angle starts at A and hits the circumference and bounces back to B, there will be another angle here. But in both cases, the angle is touching the circumference and both of them start at A and finish at B. In that case, the 2 angles are equal. Now, I know you all seen a kind of mountain top here and a mountain top. So you assume that this is A and B, but look at this. what is the arc in this question? What is the common arc? There is no common arc for this particular question. So it is not rule one. It only tricking you because you seen something touching the circumference and you seen something touching the circumference, just like here. But both of them have to start at the same point and end at the finish, the same point. Right? So we all agree, for those who thought it was rule one, you all agree it is not rule one. Just confirm with me on the chat there, right? And of course, the eyes must be looking in the same direction. Now, this one here, the eyes are looking in the same direction, but it still doesn't have a common arc. So let me slowly build up to this question. If I have a circle, what's the total amount of degrees in a circle? Like if I were to add up all the angles, you're supposed to get 360 degrees, right? So a circle is 360 degrees, just like in primary school, it hasn't changed. So if I come and tell you that I have a circle and piece is 100, how much? Oh, that's horrible writing here. And piece is, let me give this here. And this piece is 100 degrees. How much is the piece behind it? If the whole thing has to be 360 and only piece is 100, how much is the remaining piece? 260 degrees. It has minus it from 360, right? Do you all see that situation here? The piece behind the 100 will be 260 degrees. Great. Because a full circle is 360 degrees. Now, let's go to the side over here. Any four-sided figure in the world, whether it be a rectangle, a square, a trapezium, any four-sided figure in the world, the total amount of degrees inside, keyword, inside of it is 360 degrees, not 180. A triangle is 180, but any quadrilateral, any four-sided figure is 360. Look at this crazy looking shape in the middle. Well, let me draw that alone. One side, two sides, three sides, four sides. This is a quadrilateral, just a very strange looking quadrilateral. And all the inside angles have to add up to how much? 360. Now remember, you just learned that this inside funny looking angle is 260, but he's still inside the shape. You know here is 50. I told you here was 40. Do you think you could find the missing pink angle now? Right, and the correct answers are coming up. You're adding up all the angles and minusing it from, Carissa, please try it back, right? Remember, you're adding up all the angles inside the shape and you're minusing it from 360. Add the 260, add the 50, add the 40, right? And minus it from 360, right? And just checking through everyone's answers, right? 260 plus 50 plus 40, I believe, giving you 350 degrees. Minus it now from 360, and you will get 10 degrees. This angle here is 10 degrees, right? So the thing about it, this shape inside the circle, it resembles a triangle. So your brain is saying, oh, it's a triangle. But when you look at it carefully, it's not a triangle. It's a weird looking quadrilateral, but a quadrilateral nevertheless. Okay, right. So take out here. Let's not get us off the recording. All right. So this question here, draw this diagram as well. I'm only asking you to draw this. Draw it first, and then send the answer. Please, some of you all are sending the answer before you draw it. I want to make sure you have this diagram in your book first before you start sending answers. Okay, so let's please confirm if this is a cyclic quadrilateral, because it's real easy for the examiner to fool you. For it to be a cyclic quadrilateral, the four-sided figure have to be inside the shape, well, it's inside the circle, so that's a good start. Then you have to ensure that the vertices, the corners, are all touching what? The circumference. So yes, all of them are touching the circumference, so it is a cyclic quadrilateral. In a cyclic quadrilateral, the opposite angles, if you look back in the notes, the opposite angles must be equal to 180 if you add them up. So 50 plus what will give you 180? Well, it has to be 130 degrees. Opposite angles, when you add them up, must be 180. In other words, all you simply did was take 180 and you minus the 50 to get the 130, right? Right. So for those who got it wrong, you at least saw your mistake, right? Opposite angles must add up to 180. Right. Now the question, to be honest, the question, like a question easy like this will not come by itself in the CXC, right? Will not come just like this in the exam. This will just be part one to the question. So let's make it harder. I want you to adjust your diagram now. From here, connect a line to the center and bounce it back to here. If you have a different color, do that so it will stand out. Everyone add that into their diagram. Right. Now I am going to tell you this angle here is 42 degrees. I want you all to find this green angle over here, the green one. We're putting a dot by it. Try your best to find the green angle now. Now, if you look carefully, you might see a rule number 2 mixed into that question. It has the pink line, so I'm going to draw that in pink, right? And then you have that black line on top of it. So if you eliminate the underneath portion and you just pay attention to this part here, this is what you're going to see, rule number 2. Now, just like we did today, if here is 50 degrees, the one at the circumference is 50, then this one would be twice its size. So what I'm really trying to say is over here is 100 degrees. But we use rule 2 to figure that out. But that's only part of the puzzle. We want to find this angle here. So if we draw back this shape now, from the pink line go down. So we have this now. Isn't that a four-sided shape? Any four-sided shape, the total amount of angles is 360. We just encountered that. So if we know here is 100 now, we figured out here a long time ago was 130. I was nice enough to give you this as 42. Shouldn't it be super easy to figure out the green angle now, the one with the dot? You add up all three and you minus it from 360 and you will get 88 degrees. For those who got it wrong, please make sure you add it up and physically see the 88 and then confirm it with me on the chat that you finally got it. All right? Right, but a lot of y'all got it out before I explained it, which is all right. So here we go again, and you're seeing a kind of four-sided shape again, if you look carefully, right? So keep it, since you're seeing something looking like a four-sided shape, maybe it's a good idea to look at rule number 4. So here's the thing. You can actually get out this question by working out y first, okay? So what I'm going to do, I'm going to separate this diagram into two diagrams. Here's what I'm going to do. I'm going to start off with him, draw here, draw up to here, and come back down here and go back. I'm going to forget about x for the time being. So let's draw this line, go up to the 40, come back down to this point, and then connect back to y here. So if you look at it like this, right? Over here is what? 40, and over here is what? Y. Or, right, you could also have this diagram from y to here, bounce back to x, and then return back to y. So let's draw that shape. Go here, bounce back here, come back here, and go back. So in a case like this, you have x here, and you also have y again, right? You'll notice in this question, there are two cyclic quadrilaterals. Does that make sense? Look at it. The first shape I drew, all of them did touch what? The circumference. And in the second diagram, all of them touch the circumference. So you have two cyclic quadrilaterals inside the shape. We now said, according to rule number 4, the opposite angles, right? The opposite angles add up to how much? 180 degrees. So if here is 40, then over here has to be 140. So we know here is 140 degrees. Now, if it's 140 degrees in this diagram, it's still 140 degrees because both of them is y. And since you have another cyclic quadrilateral here, the opposite angles have to add up to how much? 180. So if here is 140, then over here has to be 40. 140 plus 40 is 180. So at the end of the day, x is 40 and y is 140. Now, that's the first way of getting out the question. But I think some of yours saw a different way to work it out. You could have also used rule number 1. Everyone turn back to rule number 1. Go back in your books. And rule number 1 simply states, right, that if you have an arc, I'm going to draw this red, well, terrible looking arc here in red, well, pink. You'll notice that you have an angle starting at A, it hitting the circumference and bouncing back to B. According to the diagram, that's 40. And then you have another angle starting at A, hitting the circumference again and bouncing back to B. According to rule number 1, these two angles are equal, okay? So that means over here would be 40, but we got 40 anyway if we had found y first and applied the cyclic quadrilateral rule. So either way, you're going to get the same answer. And once you realize here is 40, then you get reason out over here is 140. 40 plus 140 is 180. The examiner is not going to care which way you do it, okay? Once you write your paragraph explaining how you got the answer, and like I said, the writing of the paragraph will be later on. Let's just focus on getting the answers, okay? For those who got it wrong, do you all understand it now? Right? All right. I'm not going to ask you to draw this one, right? Because you're going to have a lot of problems drawing this one. Now, the thing about this question, right, just not to confuse anybody, I'm going to erase the answer here. The answer is supposed to be 100, but you're not supposed to know that, right? Now, in CXC, right, whenever they want you to find an angle, they could give you 3 letters. So if they want you to find the angle ABC, you're probably wondering what is the angle ABC. What you have to do is trace the letters A to B to C, and it's always the middle letter. They want you to, well, the answer you're aiming for, you see this pink angle? It's supposed to be 100 degrees. I want you all to reason it out. Use your rules and prove to me that this angle is 100 degrees. By just looking at this, which rule do you think it is? It only have one rule that resembles this particular scenario. That cannot be rule 1. Kimberly, that cannot be rule 1. So you have 2 tangents. These lines that are grazing the circle are what? Tangents. Okay? According to rule number 6, and to the explanation that I gave you, you actually have to mix it with rule number 5. But what is rule number 5? Rule number 5 says that if you have a radius starts at the center of the circle, and if you have a tangent to where the radius is touching the circumference, the angle between the radius and the tangent is always 90 degrees. If you look back at rule 5, you will see that written. So here's the center of the circle. Here's a radius, and here's a tangent. The angle between a radius and a tangent is 90 degrees. And you have one underneath here as well. The angle between a radius and a tangent is 90. Now, last week I told you that this line from the center of the circle to the outside, where the 2 tangents meet, will split the shape into 2 equal pieces, which means if here is 40, then over here is also what? 40, right? So if you look closely now, you have a quadrilateral. Look at it. You have that, that, and that. Here's B, here's A, here's D, and here's C. It seems that we are bouncing up a lot of quadrilaterals today. And all the angles in any quadrilateral is 360. So if you know here's 90, and here's 90, and here's 80, 40 plus 40 is 80. Shouldn't it be real easy to figure out this angle? Add up all 3 angles and minus it from 360 and tell me if you see 100 degrees appear on your calculator. Oh Lord, well, if that last question looked hard, well, then this question is going to be a little hard. I'm not going to ask you to draw this one, but I did give you a hint, right? Now, in this question, they ask you to find the angle BAD. So let's try to at least reason out which angle that is. BAD, let's trace the letters, and it's always the middle letter, A. Always. BAD. They want you to find this pink angle here. Right? Let me just draw that a little better. So that's the aim of the question, right? To find that pink angle. Only from here to here. And I gave you a hint. Let me explain. Some of y'all would remember this from Form 1, somewhere around there, where you have alternating angles. Alternating angles is when you have 2 parallel lines and you slice them and you get a kind of Z. The angle to the front of the Z is always equal to the angle to the back of the Z. So let me draw that in a different color here for you. Right? So if here's 30 degrees, over here is 30 degrees. If here's 22, here's 22. Right? And just to remind you, I don't think it would make much sense to draw this diagram. I think it's a little too complex for persons who probably do not like drawing. So you just focus on getting out the question. Yes, it does. So we're looking at rule number 7. So make sure you have your eyes fixed on that rule in your notes. So rule number 7 said something about someone on a skateboard. So if you look at rule number 7, there's the road, and then there's what? The skateboard. That's the pink line. So the person doing a little stunt on the road, right? And then you have the legs standing on the skateboard. One leg on the beginning of the skateboard, touching the circumference, and the other leg is at the end of the skateboard. So I think you all seen that scenario here. Look at it. If you look at the scenario, the 32 is supposed to be there. Remember, the angle between the skateboard and the road is equal to the angle between the two legs here. So here's 32. So what I'm trying to say is over here is also 32 based on rule number 7. But that's just a start of the question. The aim is to find this angle here. Now I want you to focus on this rule here, the alternating angles. Look for two parallel lines and look for a Z angle, alternating angles. If you look over here, here's a parallel line and here's a parallel line. And of course, there's a line connecting the parallel line. So I kind of drew it here. This line is this line. This line is this line. And there's a line connecting both of them. Now, you're all seeing the Z there, right? That's connecting the two parallel lines. So if here's 32, to the back of the Z, to the front of the Z is 32. So if here's 32, then over here is also 32. What kind of triangle is this on top here? You notice the length of this side is equal to the length of this side. Last week, we did a lot of work on isosceles triangles. Do you think you all can take it from there? Knowing that over here is 32, and this is an isosceles triangle, okay? You should be able to take it from there now. In an isosceles triangle, you notice the two similar sides are going down this way. Last week, I gave them names, the legs. So the angles by the legs are always the same. So if here's 32, then over here is also what? 32. Shouldn't it be real easy to figure out this angle now? Because all three angles in any triangle, it doesn't matter if it's an isosceles triangle, has to be 180. So you think you can quickly figure out this angle for me at least? Add 32 and minus it from 180. Just this angle up here. And that will help us a great deal. Right, I think we get in 116. 32 plus 32 minus it from 180, we gain 116. Now look at this. I'm going to extract this shape and I'm going to leave out this line here. So I kind of drew it here. We're trying to find this angle here. I put in a question mark here. That is the pink angle. And we just learned that this angle here is 116. That's this guy here. Isn't this a cyclic quadrilateral? He touching the circumference, he touching, he touching, he touching, and it have 4 sides. Shouldn't it be real easy to figure this guy out now? Or turn back to rule 4 and see the rule about the cyclic quadrilateral. Sachin, correct. Alia, correct. Haley, correct. Paris, correct. And Anisha, correct. Right? Right, the center line did play a lot of mental tricks on you, right? If you eliminate that middle line, you're going to realize, wait, no, that's a cyclic quadrilateral. And the answer would be 64, because opposite angles in a cyclic quadrilateral have to add up to how much? 180. So he has to be 64. Run it through back in your head, right? Half a minute. All right. Don't draw it. You just start working it out. Once again, if you want to draw it, feel free, but it's not mandatory. 2. Now, I don't want to give away the second part, right? But the first part was BOC. B to O to C. It's always the middle letter, but it's in this direction this time, right? B to O to C, no, not the other side, this side. If you look at rule number 2, but you turn your book upside down, right? Physically do that. Go to rule number 2 in your book and turn it upside down. And rule number 2 will look like this, right? Where you have one touching what? The circumference and one touching the center. And both eyes are looking in the same direction. Both of them looking what? Upwards. Remember, the one at the center will always be twice as large. So if he has 58, if you multiply him by 2, you get 116. So that's the easy part of the question. He is 116. But the second part of the question, now some of you are kind of confused about what they're asking here. OCA. So let's trace it. O to C and then to A. It's always the middle letter. It's this angle here. O to C to A. So concentrate on finding this angle here. I've given you a hint. Somewhere in that question, you will see an isosceles triangle. Look at it carefully. There is an isosceles triangle. Isosceles triangle. So remember what an isosceles triangle is. Two sides must have the same length, right? Two sides must have the same length. From O, with O is the center. So I'm going to put O here. O to C, isn't that a radius? Isn't O to B another radius? Shouldn't two radius have the same length in the same circle? Everybody agrees with that. From O to C is a radius, and from O to B is another radius, and two radius must have the same length. So if I connect it now, that definitely is an isosceles triangle. So we know here is 116. That's this 116. Here's the vertex angle. Do you all think you all can find the remaining angles? These two angles will have the same value. Those are the base angles, the angles created by the legs. You have to minus this from 180 and divide it by 2 because it's been split into 2 equal pieces, the remainder. Right, so Naima correct so far, right? Lala correct so far, right? Sorayas correct, right? Somebody got the final answer to be correct. Kimoy, Thomas, correct. Right, Darian Charles on the right track. So here's going to be 32, and here's going to be 32. Your mind, like I said, is 180 minus 116, and divide the whole thing afterwards by 2. So that means this angle here, now look at it carefully. That means, I'm going to get the color coded. This angle here is 32. I know this one is 32, but I'm just going to put in this one. If you all look carefully now, you all will see rule number 7. I'm sure some of you are raising your eyebrows. It's like, what? What rule 7? I don't see no road and skateboard. But if you look at it carefully, I'll help you. There's a road here. That is this line. Instead of the skateboard going this way, it's going this way. Well, and it's a little bit steeper. The skateboard, I'm going to draw it in pink. It's a little bit what? Steeper. So he's doing the stunt the other way. And his 2 legs, this is the skateboard here, look at it. And his legs start at the beginning, go to C, and go to the end of the skateboard. Here's B, here's C, and here's A. there must be an angle between the skateboard and the road. So here's 74. How much is the angle up here? The one with the dot. How much is this angle here? According to rule number 7. What would be the angle up here? The angle also has to be what? 74. The angle between the skateboard and between the legs are the same. So you know what they're really trying to say is? Ignore this middle line here. They're really trying to say this whole angle here. Let me draw that. From B to C to A, that whole angle, that is this angle here, is 74. And you kind of split it. And you know this portion is what? 32. Look at it. The whole angle is 74. This portion is 32. How much again do you need to complete it to make it 74? It will be 42. 74 minus 32 is 42. Okay. That one took me a while to figure out. All right, now this question only looks scarier. Oh, sorry. But to me, it was actually one of the easier ones because if you look at this carefully, didn't we do this scenario earlier today? I think it was question 4 or 5. Starting at the center, going out to outside the circle. We did one similar to this just now. So it only looks scary, but it's pretty easy actually. So if you turn to rule 6 and rule 5, right? I mean, it's kind of both of them combined together. The angle between a radius and a tangent, this is a tangent, so just grazing the circle. This is 90 degrees. Radius and the tangent, 90 degrees. This here is a quadrilateral. So you're adding 90, 90, and 40, and minusing it from 360 because a quadrilateral is always 360. If you do that, you're going to get here as 140, I guarantee you. Right. For those who got this piece wrong, you understand the mistake? You're adding up 1, 2, 3 and minusing it from 360. Right. We're moving on to the next part here now. For Q, that's pretty easy. That's rule number 2. Rule number 2 says that if you have an arc, and the arc could be on any side of the circle, it could be underneath the circle, on top of the circle, to the left or to the right. So if I have point C here, and I have point B here, we get a different color. And look, and I connect B to C. Isn't that there an arc? It's just piece of the circumference. You will notice that there's a line going from C to A to B. Leaving C, it hits the circumference key point and bounces back to B. That's the angle Q. But then there's another angle starting at C again, but it goes to the center, which is point O, and it goes to over here. Remember, we just found here to be what? 140 degrees. Here's an eye, here's an eye. Both of them looking in the same direction. The one at the center is be twice as large as the circumference. So that means Q is 70 degrees. Divide this by 2. Right, so this was a mixture of rule 5, 6, and 2. Right? Yeah, this one was easy, right? I've seen this exact question come in the CXC exam as well. Right. All right, now this one here, trying to figure out, there's a little blotch here. All right, so take a look at, let me see if I could figure out that angle there. For this to be an isosceles triangle, that means two angles have to be the same. It could be this angle and this angle, or this angle and this angle, or this angle and this angle. The point is, we have to try to prove that two angles have the same value within this triangle. So if here's 80, is the one inside the triangle an isosceles triangle? So forget the one that's outside. From here to here is a radius, and from here to here is also a radius, because two radius must have the same what? Length. Do you all think you all can find this angle and this angle? Because these are the base angles. If here is 80, I know you all can more than find these two angles. Carissa, correct. Clement, correct. Okay, real people get it correct. Right? Remember, it's 180 in a triangle. Here's 80 degrees, so we minus 80, and then we simply divide it by 2. And that will give you here as 50, and here as 50. Right? Anisha, you saw a mistake? Right. Remember, when you're working this out on a calculator, do not type it in straight on the calculator. You will get 140 by mistake. You have to work out the top and write down the answer. 180 minus 80 is 100 divided by 2. It will be 50. Right. Now, we're not finished. We're trying to prove that this triangle here, the one that's outside the triangle, outside the circle, that one is an isosceles triangle. Do you all think you all can find this angle here for me? It should be real easy. Look at rule number 5. Right, correct answers. Look back at rule number 5. Let me refresh your memory of what rule number 5 says. Rule number 5 says that if you have a radius, so from O to S, that is here, is a radius, and you have a tangent, the angle between the radius and the tangent will always be 90 degrees. So do you all see that? A radius here and a tangent here. That means that this entire angle is supposed to be 90 degrees. But we have 50 degrees here already. How much again do we need to make what? We need 40. So you prove it, look at it. These two angles are the same. And if you find this angle, you will get how much? 100 degrees, right? Because once you reason out, here's 40. 40 plus 40 is 80. Minus it from 180, you're going to get 100. This is an isosceles triangle. In an isosceles triangle, two angles have to be the same. So you see both of them are 40. So you just prove that it is an isosceles triangle. And the main rule here was rule number 5. Take a half a minute again. I will see number 10. Oh, Lord. Well, definitely do not draw this one. Right, so get started. Feel free to send your answers. I'm not going to be able to comment because I need to figure it out as well. Remember in rule number 5, let me use this circle here, right? If you have the center of the circle, and you have B here, and you have a tangent, right? Remember the angle between a tangent and a radius, and this is a radius because it's starting at the center, is 90 degrees. So if you know here is what, 62, you need 28 again to get what, the 90. So 28 plus the 62 is 90. So we could start off here, right? So I know it's kind of small here, but I'll just put a little arrow here and put 28 degrees. So we know that small pink angle is 28. Do yourself a favor. Find this blue angle now. And once you find that blue angle, you'll be the next part of the puzzle. How much is that blue angle? Only focus on the blue angle. Rohan, correct. Right. Anisha, correct. Right. Carissa. Okay, so I think a lot of people didn't fall for that trick. From O to B is a radius. And from O to A is another radius. Two radius must have the same length. This is an isosceles triangle. So if here's 28, that is this guy, then over here is also 28. So those are the base angles. It should be super easy to find x now. Isn't this x? You have two angles, find the missing angle. The angles in a triangle add up to 180. Anya, check it back. Remember, you're adding up these two, 1, 2, and minusing it from 180 to get a balance. Sydney, check it back. All right. 28, so 28 plus 28 is 56. Minus it from 180. I am getting 124. I'll put it in here. 1, 2, 4. Right. For those who didn't get that, I'm not too sure if people are just typing the wrong thing by mistake. I know some of them are using a phone and you're trying your best to type and the wrong numbers just come out. But it's supposed to be 124. So at least we have x now. X is 124 degrees. All right. We have to find y now. Okay. Well, my advice to you is to find this green angle. And that should be real easy. To find the green angle, we did a question. We did 3 questions like this today. This could be the third one. The third time you're doing it for the day. Find this angle here. That's the rule 5 and 6. Concentrate on this section here. So remember the angle between the center and a radius is 90. Between the center, radius, and the tangent is 90. This is a 4-sided figure. Here's 40, here's 90, here's 90. Add up all 3 and minus it from 180. You're getting 140 degrees. Check it out. 140 plus 90 plus 40 plus another 90 is 360 degrees. All right, so we're getting there, right? Now I want you all to look at this junction here. You have one line coming here, one line coming here, one line. It's like a 3-way junction. Let me draw that better for you guys. This line coming here, this line going, so it's like an upside down Y. We know here is 124. We know here is how much? 140. Isn't this a full circle? Like if we were to find this piece here, won't this give us a full circle? A circle is 360 degrees. So if you know here is 124 and you know here is 140, couldn't you just simply add them and minus it from 360? So how much are you getting here? Add these two and minus it from 360. All right, right. Christian, I think I get the same answer. That's not right. Right, Alia, correct. Roshan, Pooja, Sridev. Right, so you add the 2 and you minus it from 360 and you're getting 96. It should be super easy now. To find y, let's look at this triangle here. Here's O, here's A, and here's C. We just figured out here's what? 96. Isn't this an isosceles triangle again? From here to here is a radius, and from here to here is another radius. Y is one of the base angles. So minus him from 180 and divide the remainder by 2, right? Because you're splitting the base angles into 2 equal parts. Right, so let me work it out. I haven't done it as yet. All right, somebody put 32 by mistake. Check it back. The answer is not 32. Ashrina, check it back. 180 minus 96. After you minus it, then divided by 2. This one is not rule number 4. Remember, for rule number 4, the whole 4-sided figure have to be inside the circle. Not a piece cannot be outside. The answer you're supposed to get here is 42. All right, don't worry, guys. This is the last question we're doing for the night. I just want to make follow up on the homework, right? So give everybody a few seconds just for this to soak in. You're going to click on the Maths Classroom for the homework. So click on Maths Classroom, and it will change to this, right? Click on Maths Classroom, and you'll see that the Monday recording is up, but you're not in the Monday class. The Tuesday recording from last week class session 1 is up. By tomorrow, you will see session 2. So in case you want to review it and whatnot. When you scroll down, you will see the Saturday recordings. It's mandatory for everyone in this class to review all the Saturday recordings. You don't have to attend Saturday class, right? All I'm asking you to do is view the recordings. The Saturday class will handle the first 4 questions in the CXC paper. You know, the easy topics like, well, not easy, but the topics like areas and volumes, those things that you're supposed to have covered from Form 1 to Form 3. The Saturday class is reviewing all of those topics. And those same topics will come for your CXC exam. So make sure and follow up on the Saturday classes. It's mandatory. Also, if you scroll down, you will see lesson 1. When you click on lesson 1, you will see 21 videos. I know that's a lot of videos. I'm not asking you to do all 21 videos for next week. You have till October the 4th. And you can skip videos 8 and 9. To put that in writing, I have it here. So I know it's a lot to take in. So screenshot this. And this is a summary of what the homework is, right? You're going to lesson 1, you're doing videos 1 to 21. You're skipping 8 and 9. The test will be on October the 4th. It's already supposed to be October the 4th. I think that's a Tuesday. And please ensure that you review the Saturday videos. Once you completely understand what the homework is, just say, hey, understood, and you're free to leave.